Hello everyone. So today's code is about the machine learning classification using decision tree and the support vector machine, that is SVM. The program creates a sample dataset, trains two different machine learning models, tests their performance and visualize how they classify data. The main techniques which is used are classification, which is predicting categories or the classes. Second is decision tree algorithm, which is classification using tree-based decisions. Third one is a support vector machine (SVM), which is classification by finding the best boundary between the classes. The fourth one is a model evaluation, which is checking accuracy and the performance of the model. So what is a classification? Classification is a machine learning technique where the model learns from the data and predicts which category an input belongs to. For example, email classification. So email classification, email data, it goes on the model. It decides whether it is a spam or not a spam. The model predicts class 0 or the class 1. Second is what is decision tree. A decision tree is a machine learning algorithm that makes decisions by splitting data into smaller groups using the conditions. If it works like a flowchart, it creates a nodes which like a questions or the condition, then branches which is possible answers, and leaves which is the final prediction. The advantages of it is easy to understand, works with the classification problem and gives visual decision rules. Then what is it? Third one is what is the SVM, which is support vector machine. SVM is a classification algorithm that separates different classes by creating the best possible boundary. The lines separating both groups is called a decision boundary. SVM tries to find the boundary with the maximum distance from the both classes. So distance is called the margin. Advantages of SVM is that works well with small datasets, effective for classification and finds clear separation between the classes. So firstly we import the libraries. First one is NumPy, which is used for mathematical operation and creating the arrays. Second one is the matplotlib, which is used for the creating graphs and visualization. Third one is sklearn, which is loading built-in machine learning dataset. Then from sklearn here is a train test split, which is used to divide data into training data and the testing data. Then plotting a tree, which is used for plot the decision tree model and tree visualization function. Then here is the SVC, which import SVM classifier. So SVC means support vector classifier, which import the SVM. Then accuracy score and the classification report, which is used to evaluate model performance. Firstly, we create a data set. XY is equal to datasets dot make classifications, which create artificial classification data. So n samples is equal to 200, that creates 200 data points. N features is equal to 2, that means 2 input features, for example feature 1 and feature 2. So n information is equal to 2, so both feature help in a classification. And then n classes is equal to 2, which creates two categories like a class 1 and class 0, and random state is 42, that means it keeps generating data the same every time. Then we splitting the data into a train and a test model. So x train x test, y train y test is equal to train test split xy. Test size is 0 3 and random state is 42, that means it divides the data into 70% of the training data and 30% of the testing data. So training data used to teach the model and the testing data used to check the model accuracy. Then we use the decision tree. So decision tree model, it creates a decision tree model which has a max depth of the depth is 3, means the tree can have maximum 3 levels, which has purpose of the prevents the tree from the becoming too complex. Then df.fix x train y train, that means training the model, the tree learns input features and to the class. Then y predict dt.predictX test, which is used to train model to predict the test data. So it gives output of the predicted classes. Then second model is the SVM model, which creates a SVM classifier. So the kernel is equal to linear. That means SVM creates a straight decision boundary. Then SVM.fit extend by train. That means train SVM model. It learns the best separating line. Then vibrate SVM, which predicts the classes for the test data. Then we are going to evaluate the model, the decision tree accuracy. So the accuracy score, here the accuracy score of the y test y prediction dt, it calculates the correct predictions or the total predictions. Then classification report. So the classification reports shows the precision, that means how many predicted values are the correct, and recall how many actual values were found. So the F1 scores, which is balance between the precision and the recall. Same this way is done for the SVM here. Here and the accuracy score and the classification report. And then for the visualization, we use plt.figure on the size is a 10:6, which creates a graph size. Then here plot tree dt in field is equal to true, which plot the tree. Display the tree, which shows the condition branches and the final classes. Here is the SVM decision boundary, which create create a scatter plot, which shows the data points, different colors for the classes. It plot the GCA. Then here ax dot get xlim, and y limitation is gets a graph limits. The line space creates a value between the limits used to draw the boundary. Then mesh grid. This function is used to create a grid points for the graph. Then SVM decision function, which is calculates the distance of the points from the SVM boundary. And ax dot contour, which is the SVM decision boundary. The title is the SVM decision boundary, and it is shows by plt dot show. This is the output of the code, where the decision tree result, the accuracy is 0.83, the precision, the recall, the advanced score, and the support. Here is the accuracy, macro average, and weighted average. Same for the SVM result, the accuracy is 0.81, the precision is here, the recall, the F1 score, and support. The accuracy, macro average, and the weighted average. Here is the decision tree graph, which shows the tree structure, which contains the decision conditions, which splits and final predictions are here. It explains how the model makes the decisions. And here is the SVM decision boundary graph, which shows the data points. Here blue and red are the data points, the classes, that means class 0, class 1, and the separating line. Here is the separating lines for the class.